Hey there YouTube, Superbrain AK here, and this is a Furman PL-8 Series 2 Power Distribution Unit, or PDU for short, which is just another way of saying it's a fancy power strip that you can mount in a server rack. It's got the ears on the side here, and this guy is meant for audio equipment, so it's got some extra filtering, well, special filtering, and some quality of life features, like these little lights that you can pull out. Now I have repaired and modified this one. So I repaired the power switch here because it had blown out, which caused me to add in a soft start circuit here for this outlet. And I also have some inputs on the back for a trigger input, so it can be turned on remotely. So I'll first explain all the filtering that it has, and then I'll show you the schematic of the circuit that I made. So I'll get you up higher and take a look inside. So you can see the inside of it. It's got power cord coming in over to the switch, and then it's got a little breaker, 15 amp breaker, and then that goes to the input of the circuit board. Goes through MOV, some relay for some reason, another MOV, then this inductor, which this inductor actually only has one winding around it on the hot side, so it doesn't have your typical common mode filtering like you would see in a power strip or a line conditioner. You'd see something like this in one of those, where it has the windings coming in and wrapping around and then going out, and that gets rid of any fluctuations on the hot and the neutral. But you don't really need that because your common mode filtering is gone, because most audio equipment just uses a linear transformer, so that isn't necessary. So they just put this inductor here to kind of isolate the hot side from your output, to smooth out any spikes or dips. Now it also has this kind of filtering, along with your class X capacitors, but it also has this little guy, which is the bridge rectifier to nowhere. I'll get you a little bit closer. So here's that bridge rectifier to nowhere, and it's got on the output of this inductor, there's the hot side, and that's the neutral side. So that's going across this capacitor, and that goes nowhere except for this 20K resistor. So that's going to charge the mains directly on this capacitor, and then it'll get slowly dissipated by this resistor, which is about 10 milliamps. If you say the voltage is at 200 volts, that's only going to be 2 watts. So it'll be less than that. Less than 10 milliamps, less than 2 watts. So the reason why this is here is to chop off any peaks on your sine wave. So you turn something big off, you're going to get a peak on your sine wave, and so that peak is a higher voltage going to charge into this capacitor, and then afterwards it'll get dissipated by the resistor. So those peaks on the sine wave will go into your amplifier's capacitor and cause the voltage to spike up, kind of like that. And so that's where you'll get pops and whatnot from some dirty power. So this just chops off those spikes just a little bit more, so it's less noticeable on your amplifier. So as far as filtering goes, that's pretty much it. You got your outputs down here, and then that's going to the plugs on the back here. I don't know if you can see those, but there you go. So I'll get you zoomed out and take a look at my soft start circuit that I made. So you've got the output here, the filtering that's going on this, going over, and then this wire. You can see hot and neutral. Hot comes into this circuit and then back out over to this socket on the right next to the power cord. And the neutral just goes straight across. And this has 2 relays and then a negative temperature coefficient resistor. So I'll take you to the schematic and we can talk a little bit more detail about what it is. So here's the schematic, which is available on my GitHub, either a PDF version or a KCAD schematic file. And up here you've got the line in and line out. It doesn't matter which way they are. And there's the thermistor, and then you've got the 2 relays. And so that's the main side of it. And then you've got the low voltage side down here. And then this area over here is actually mounted next to the audio jack 1/4 inch socket. So we'll start there. There you can see it. So you've got the jack here, the shield goes to ground, the tip goes to a 10K resistor, and then you've got a Zener diode which protects it from a high voltage on there, which I just put it in just to make myself feel a little safer. Keep it protected. We got another 10K resistor, just in case this is actually 12 volts. And then another 10K resistor to ground, which causes there to need to be more current flowing in order to turn this transistor on. So it can't just float on, get charged or whatever. So when this goes high, it will turn on this NPN transistor, which will go low, short it to ground. Then you have a single pole triple throw switch, and I only have a double throw switch, so you only have trigger and on in the actual device that I made, but you can always add a triple throw and that's what it would do. So when this is turned on, if the switch is in the trigger position, that will then turn on this PNP transistor, because that's connected to 5 volts. 5 volts will flow through this current limiting resistor, through this transistor, and back to ground. Now if it is in the off position, this will never turn on. And if it is in the on position, it will be constantly connected, and so it'll just turn on. Now I have this capacitor here just to give it a little bit of hysteresis and delay from turning back off, I believe. And so that gives it a little bit of buffer in case this switches. You know, it's a little bit of debouncing basically, in case this switch is corroded or you've got a bad connection here. that causes the other relay to not turn on and off super quickly. So once this is turned on from the switch, either in the trigger or on position, 5 volts is going to start flowing through here, through this diode, charging up this capacitor, and then also flowing through here, through this 3.3K resistor, turning on this transistor immediately. And you can see that that transistor is connected to this relay, which turns on through this 12 volts. And then that connects your input through the negative temperature coefficient thermistor through the relay and out. So this is normally a high resistance. When the relay turns on, a large amount of current flows, but not a catastrophic amount of current. It's going to warm this up. Its resistance is going to drop, but it won't go down to 0. It'll get close-ish. And so while that current is flowing through, everything's charging, and this is warming up, you've got this other capacitor that was charging, and so it's getting charged, and that is connected to a TL-431, and this is its reference pin. And so when the TL-431 sees 2.5 volts on this pin, it will start to shunt. So as soon as this capacitor reaches 2.5 volts, the TL-431 will shunt, pulling this to ground through a 22K resistor, pulling this PNP transistor to ground, and it'll turn it on. And so 12 volts is going to flow through here like that. And then it'll also cause 12 volts to flow through here to the emitter, out to, the collector, out to this relay, back to ground, which turns on this relay, which connects your line in to your line out, shunting out whatever connection resistance is here. And so now you have the full power to your amplifier. And the very similar thing happens in the opposite direction. Either you flip the switch to the off position, or the trigger turns off. This goes back down to no voltage. This guy turns off. This relay turns off, but it is still connected directly. This capacitor is going to start discharging, and when it gets below 2.5 volts, this transistor will turn off, and this relay will turn off. And so your device will then get abruptly turned off. So there's my schematic. Hopefully that made sense. I know it's a lot of rambling, but let's get back to the tangible. So here is a video of it in action. 24.6. $190 watts. $44C. 30C. So that's how long it takes. $227. 50.4C. So, you can see my little circuit board here. It seems to work pretty well. It's got a plugged in wire here that goes off to the switch and 1/4" jack that I've mounted in the back here. Now I'll show you that. There you can see the 1/4" jack and the switch. So this way is the trigger going to that. That is just plain on. And I only have a 2-throw switch, so there's no off position. So trigger being off is your off. So here's a close-up of my circuit board. You got 12 volts DC coming in here, charging up this capacitor, which goes to this 5-volt regulator, 7805, going to this capacitor. And here is that PNP transistor, which is Q2 in the schematic. I've got Q1 actually over here on the back of the switch, or actually on the back of the 1/4" jack. And so there's that Q2, which is PNP. So when this gets pulled to ground, that turns on, supplying power to the NPN to this relay, connecting the NTC across. And then that goes through this diode, through this resistor, charging this capacitor, going to the TL431 there. Once that gets the 2.5 volts, it shunts and then turns on this PNP transistor, giving 12 volts to this relay, which connects directly across. And then the opposite happens when it turns off. This relay turns off, then this relay turns off. So yeah, that's my circuit. And then over here, supplying it 12 volts, is this transformer, which I did have to replace from the one that it originally had, which was this guy. That was a 14-volt transformer, and so the relays were getting 16 volts when it was rectified. So I had to drop the voltage down. And this little circuit in here is pretty simple. Potentiometer to a transistor, which dims these little light tubes, so that way you can see your console when the lights are strobing. And then it also has this switch, which connects to the BNC jack back here, giving 12 volts for some other lights elsewhere, which I don't have plugged in. Now, this was connected directly to the 12 volt unrectified, so it was AC coming out, and that's grounded, so I needed to change that just to make things a little bit simpler for me. So yeah, that's pretty much it. Hope you guys enjoyed this video and repair and modification. So eventually I want to add a Raspberry Pi connected to the trigger on the back to turn the amplifier on and off at different times of the day. So that way we can use the bell schedule at our school to on the big speakers in the gym. So, thank you guys for watching, and I will see you guys in the next video.